When we looked at how to find the best solutions, we realized that there were just three criteria required. That a viable solution has to be permanent. If the carbon isn't sequestered for at least 100 years, it's not a viable solution. It needs to be scalable to pretty much the level we need, which is 60 gigatons per year. And it needs to be financially viable, because it's one thing to have a good idea, but if no one's going to pay you to scale it up to 60 gigatons a year, it's simply not going to happen. So all of these fit those three criteria of being permanent, scalable, and financeable.
Where do you see the greatest immediate buy-in? What area are you focusing on?
I'm focusing on all the areas at once, in part because when people look around and they see everything is happening, their brain tells them this thing is happening. And so the one that's...
I'm sorry, because it could be ambiguous that you're focusing on all four.
Yeah.
Could you just state that as far as getting buy-in,
yeah,
that you're focusing on all those areas?
Yeah. So we're focusing on all four at once. The one that's making the fastest progress is the synthetic limestone. And they're getting very strong support from the whole concrete industry globally, in the construction industry and even architects. And then the seaweed group, one of the groups won $1 million award from the Musk X Prize, which is very exciting. And the ocean fertilization is establishing groups in, I think, at least 5 countries at this point around the world. And we're expecting several fishery restoration projects to start by well before the end of 2023. And then finally, the methane oxidation has the least traction so far, and we're right now raising between $2 and $8 million to finish the engineering testing and then do the scale up.
Can you just give me a bit of a soundbite in terms of, I mean, most of this, it's, as you were saying, it's kind of nature's science in a way. It's not like you're creating a new vaccine where we're not too sure where it's going.
Yeah, so it was curious to me, because as a physicist, who went to MIT, I figured that the answers would be technological. Just like on a submarine, they have to get CO2 out of the air, and they have a technological method for doing it. I always assumed that's what we would do in the atmosphere. I was pleasantly surprised to discover that the only solutions that passed our 3 tests of being viable, scalable, and permanent were the same solutions that nature did. In retrospect, of course, it's no surprise. Nature has spent a billion years by trial and error finding these methods. But it's also very reassuring, and I think people who are learning about this will be reassured to know that the techniques that nature has evolved and accommodated to over 1 billion years are the methods that we're using. So we're not expecting we're very much not expecting unusual side effects, because these are the methods that nature uses. And of course, for safety purposes, we are going to be checking, because anytime you do anything at scale, you get interesting surprises. But the good news is that they'll probably be very local surprises.
Can you just chat briefly about the some of the challenges from the, not saying it in a way that alienates at all, but just some of the challenges that you've had from the more established scientific community?
It's a good question. Yeah, surprisingly, the biggest roadblock so far has been the scientific community, in large part because the scientific community is designed to be conservative. When one does science, one researches the past and creates rules and abstractions and figures out what's going to happen in the future, and then gives those models, those expectations to planners to plan the future. And that's the whole idea of climate science, is to tell planners how much sea level rise will there be, how much temperature rise, how many climate immigrants will there be from places that are too hot for people to live. And that's the way science goes. Climate restoration is a project kind of activity. It's an engineering where we say, well, our customer is humanity, and what humanity wants is a climate and a planet that humans can be sustained on. And for that, we need CO2 of these levels, and here's how we can do it. And so the scientific community has been very uncomfortable because it's not scientific. It's just like, when breakfast appears on my breakfast plate, that's not scientific. It actually had to be done on purpose by somebody. And climate restoration is done on purpose, not scientifically. But I think the scientific community is finding a way to find its place in the climate restoration world so that it makes a big contribution.
Stop and start. Stop and start. Yeah. So yeah, if you could say that as a statement, something like that.
Yeah. So there's always been concerns and questions that if we restore the climate, it gives oil companies a blank check to continue selling us the oil and gas that we want. And I don't know if that's true or not, but I think we're always going to want our oil and gas until we replace our cars with electric vehicles and our furnaces with electric heat pumps. In fact, it's really important to realize that what we really want is humanity to survive and sustain. And if we have to use natural gas for a while, that's secondary, because the main goal is our survival. I don't think there's anyone who only wants us to reduce emissions, even if we go extinct in the process of doing that. If you read the climate literature, literally, that's what the climate literature says, is that it doesn't matter if we survive. No one has ever claimed that the UN climate goals are survivable, but they do take us to zero emissions. And so it's, I think, very important for people to realize our top priority is survival. And along the way, of course, we want to reduce emissions because it's healthy and economic and much better for the ecosystem.
And are you an optimist, if you could give that as a statement as well?
Yeah. I'm definitely an optimist about it happening, in part because we're making it happen. So it's sort of like being an optimist about having breakfast. Of course, I'm going to make breakfast. And if I don't make breakfast today, I'll make breakfast tomorrow. And so more and more of us are saying, I don't have anything better to do than to restore the climate. We have the technologies, we have the finance, we have a growing literature and numbers of people involved. And so we are going to restore the climate because we don't have anything better to do. We might as well just do this.
Oh, another one. You mentioned the long journey starts with that first step, and it seems that at the moment one of the first steps is still creating awareness, which is why you wrote the book, I guess. But if you could just talk about that it's just essential to kind of do the wake-up call without being alarmist that this is where we're at.
Yeah, people talk about a wake-up call on the climate, and they want to wake people up. And to have a successful journey, you need two things. You need to know where you're starting, and you need to know where you're headed. And people are sort of aware that things are in a disaster state right now. But until now, until we really built up climate restoration, people weren't clear where we're going. Now that people are almost universally agreed that we want to restore a climate that humans have actually survived long term, now we can all work together from the state where we are now, which is probably not survivable. No one claims it is, to one where we will survive, because we know what the state was for 10,000 years where humans survived and flourished. But I like to say that a journey of 1,000 miles begins with the first step, and that's becoming very aware of where you are and where your destination.
Oh, and you write about cognitive dissonance. Could you just give us a quick soundbite on that?
Yeah, when there's a new idea, and climate restoration is definitely a new idea, especially a new idea like this where you have thought it but never said it before. What we tend to do as humans is that we call this phenomenon cognitive dissonance, where the first reaction is that's simply not true. And then you don't know what you're talking about. And then, well, just ignore it. And then finally people will figure out, oh, maybe there's something there. But it's very useful in such an important and passion-driven area as climate to realize that we all have to deal with the cognitive dissonance. We've been heading towards zero emissions and what I call the Paris Suicide Accord, and now we're going to humanity flourishing. And it's a shocking change of direction. And that probably everyone listening to this is going to go through this process of denial and anger.
Great. Yeah, I think that's great for now.
Okay,
Peter.
great.